at
This
VR
conference
Siddhartha
will now
Engineering
be
College.
recorded.
His research interests are in the areas of material sciences and fiber reinforced composites and sustainable construction materials and 3D printable concrete. So currently, his working focus on mix design and testing on 3D printable concrete mixes. So Dr. Teja has received his PhD in fiber reinforced composites from NIT Warangal in 2021. From 2012 to 15, he has worked as assistant professor in Department of Civil Engineering at Vignan University. And from 2021 to 21, he has worked as Bapatla Engineering College. Now he is an assistant professor in VR Siddhartha College. He has total 12 years experience with including 6 years teaching and 6 years research experience. He has several publications in reputed and international journals. So, sir, Raviteja sir, please start the session, sir.
Okay, Mark. Good afternoon, everyone. That's a nice introduction. So I'm sharing my PPT. Okay, just a moment. Is it visible? Can anyone respond once? Is it visible? The slides and all these things. Yeah, maybe I think so. Vinpasnam, is it visible? The slides and everything? Then I will start the presentation.
Please start the session, sir.
Slides కనిపిస్తున్నాయమ్మా స్లైడ్స్ అవి
Yes, sir.
presentation కనిపిస్తుందా okay fine yeah good afternoon students. There's a little bit time delay for this. Okay, I think yesterday we had to start this presentation, but somehow we make it today. So in today's session I'm going to give a guest talk on innovation and recent advances in 3D printable concrete. So before going into the topic, so first we need to know what is innovation and all these things. So the brief contents of my talk is like this: why innovation, what is it, additive manufacturing, so what is the need for this 3D printable concrete, later on introduction about this, then introduction on how this 3D printed concrete will be delivered, and what are the field applications and the materials mix design, followed by applications advantages, and later on the main crucial important thing is challenges and further need of innovation, and thereafter the 3D printable concrete in India. Thereafter, I will discuss a small case study which Twatsa has been undergone in IIT Madras. Later, the 3D printed concrete, what we are doing in our college, that is VR Siddhartha Engineering College, and finally conclusions. So the first slide, why innovation? So what is the need of innovation? So we can define innovation such that creativity followed by invention, then innovation. So creativity is the thing which is different. That means if we are doing something different, then we call it as a creativity. If we are adding some technical thing to it, then we'll call it as invention. So if we are inventing and if you are using it, then that is called as innovation. So innovation can be called as meaningful and it should be a unique thing. Okay, so there are several definitions given by several authors, and all these definitions already you can search in Google and you can find this thing. The best thing is the knowledge applied to tasks that are new and different. Okay, that means whatever the task we are doing previously, if we are doing those tasks which are now doing in a new and different way, then we can call it as an innovation. Okay, and this is given by Peter Drucker. And here there is a difference between research and innovation. So why I'm emphasizing on this one is, as a research faculty, I will do research. Okay, for my research, I need some amount of money. So I will spend my money, and that money will be converted into knowledge. That is known as research. But when come to innovation, it is the transformation of knowledge to knowledge to money. That means now I will use my knowledge for money purpose. That means if you are innovating or if you are inventing something, that should be such that finally you get some revenue. Okay, let's take an example. If you have invented something, then you do incubation, then later you will do startup, then it's like company, so it's like a revenue. Okay, so now coming to the innovation in civil engineering, broadly we can say the civil engineering aspects can be innovated in three different ways. The first one is materials. already you know metals means in previous days the binder what we use is lime. Thereafter the Portland cement, thereafter different types of cement, then concrete, in concrete different types of cement. So there is a set of innovation in materials whatever we are using. Similarly mechanisms also, that means like beams, girders, precast panels and everything. Now as per industry 4.0, where there is a need for additive manufacturing technologies, there is a need for digitalization. So in this context the 3D printing is a have a bright future. Okay, so what is 3D printing? Actually the 3D printing is not new thing for other branches, that is for mechanical, for biotech, biotechnology and all these things. For them it's not a new one, but for civil engineering it's somewhat a new one, because actually 3D printing is a part of additive manufacturing techniques. So what is additive manufacturing? The process of making an object from a three-dimensional model. That means we'll develop a three-dimensional model. From the model we have to create an object, so that is known as additive manufacturing or 3D printing. Okay, so by using the 3D printing there are four advantages are there, such as the labor can be reduced, the production cost can be reduced, the construction time can be reduced, so that we will do everything fastly. And architectural freedom, that means if we want to construct something in a particular manner we have to adopt the normal technology, but if we want somewhat architectural freedom, that means my robots or all these things can move in any direction, so I will have architectural freedom in this 3D printing. Okay, so these are different class of additive manufacturing, of which I have shown over here. In this all, there is a technique called as material extrusion. That means the material will be extruded from the nozzle. So this nozzle-based deposition system will be somewhat example of 3D printing concrete technology. Okay. So introduction to 3D printing. So the introduction is the first 3D printer was invented by Charles Hall in 1983, and over the last decades, it's been developing, and so many innovations have been undergoing. And these 3D printers can print objects. That means I have given digital template. From that digital template, I will get the physical object. That is a three-dimensional physical object. So the printing done over here will be by layers. That means we can use any type of material, that may be plastic, metal, nylon, or any type of material I can use. But finally, the print is such that it should be extruded. That means from the nozzle, the material should be extracted from layers. First, one layer will be deposited on the first layer. The second layer will be deposited. Like that, the object has to be finally get its form. Okay, so 3D printing has applications in different sectors such as manufacturing, industrial, jewelry, footwear, architecture, engineering, construction. So like this, there are so many things are there. At present, it's been widely used in civil engineering. Okay, due to this industry 4.0. So what is 3D printing? Actually, this is a repetitive slide. It's nothing but a process of making a three-dimensional solid object from a digital file. So how to create the digital file and everything I will be explaining in the later slides. So it enables you to produce the complex shapes. That means without using the 3D printing, we'll get the shapes, but which are not complex, normal simple shapes. But if we want some complex shapes and complex types, then we have to go for the 3D printing technologies. So how does it work? Means we have to create, first thing is we have to create a 3D model. Already you got the idea. I think you are civil second, third, and final years, or maybe first year also. So you all are aware of the AutoCAD. So in AutoCAD we can do 2D and 3D. Okay, all these steps. So here for the 3D printing, first we have to create a 3D model. Okay, and this 3D model should be such that I can be convert it into a .stl file. If we are using the AutoCAD, then it will be extension of .dwg. So from the .dwg, you have to convert it into STL file, and then you have to give it to input. Then after slicing, the machine will extrude the material layer by layer. So it's the basic technology. Okay, I will explain this into further explanation in the further slides. Okay. So the first question anyone can ask is it really possible to print a building? Because whenever someone says in from your childhood, you what you will listen is print a paper like this. But now printing a building is possible. Yeah, it is possible. Yeah, because now there are so many structures which are printed. So what is the need of 3D printing? By using the 3D printing, we have design freedom. See, the structure shown over here has different complexities. The architectural freedom I can't get with normal construction. So if we want to do this construction with normal technology, I can't. It will be very, very difficult. But if I am using a 3D printer, it can construct it easily. That means the 3D printing concrete technology has the design freedom. It can make into complex shapes and different curvatures also. And the second point is sustainability. That means here the sustainability is in terms of the material. That means the material what we use will be reduced and the construction cost will be reduced. The labor usage will be reduced. So from the sustainability aspect, it's a very, very good thing. Now, what is 3D printable concrete? So 3D printable concrete is a novel construction technique. So right up to now, the before slides I have discussed about what is 3D printing. Now I am discussing about what is 3D printable concrete. So that means I have entered into concrete that is 3D printable. Okay. So the 3D printable concrete is a novel construction techniques primarily using layered extrusion. Okay. This is very important term, layered extrusion. That means the material should be extruded from the nozzle and the extrusion should be such that it should be extruded by layer. That means the material should be deposited in a layer. Thereafter, another layer should come over the initial layer. So it should be like that. The layer by layer deposit should be there. So concrete is extruded from a nozzle and automatically deposited layer by layer. And here, whatever the file, that means 3D file I have given, depend upon that it will print. So if I have given some square shape, then my printer will give will take that .wg file into STL file. Thereafter it will get the file, then it will slice. That means depend upon the number of layers, it will start printing. So it's the technique, it follows like that. So it has been proved that 3D printing concrete has advantages such as high efficiency. Already we have discussed efficiency means the construction cost will be reduced and the labor cost will be reduced. So it is highly efficient and it has high degree of freedom and it is flexible. So I can print as I wish. If I am doing some normal construction, I cannot do the construction as my wish, as per plan and as per the things I have to do. But here the flexibility to do the things as my wish. Okay, as well as environmental benefits will be there during both complex shaped and ordinary shaped. So these are all the advantages. Now, how to print? So whenever, if I want to print something, print a certain shape. So the first thing what I need is I have to create a 3D image. So that 3D image can be created by using CAD software, any CAD software, that means AutoCAD, 3ds Max or Vision 360, any software. We can use any software and you have to create a 3D image. Thereafter, the 3D image CAD information has to be converted into the .stl. It's the very important file. That means for the 3D concrete printing, we need the file such that .stl. That is the stereo lithography file. Okay, that's the primary requirement required for the printer. Okay, if I have given this .stl file, then the printer will it will analyze. So what is the depth of the layers, what is the width of the layers, what is the length of the layers, so how many layers have to print, everything it will fix. Okay, it will be, there will be software in the printer, that software will fix all these things. So here you can see some video. So here what you can see is the printer has been printing. That means it depositing the layers. Okay, first it will deposit one layer after layer, like that a building will be developed. So as you can see, this is a robotic arm printer. So this robotic arm printer has more degrees of freedom when compared to gantry girder, that will be discussed in next slides. You can see the videos and all these things, how it getting printed or how the building is getting ready. And these are the components, how the finish will be there. So this is a particular building which has been constructed using this 3D printing concrete technology. So now coming to the 3D concrete printing system. So what is the system that will be required? So it is divided into three different phases. Okay, the first phase is the computer phase, the second phase is the 3D printer phase, and the third phase is the material phase. So in these three different phases, we have to properly see whether we have in the first phase, that means in the computer phase, we have to see whether we are creating the model perfectly and whether we are dividing the layers properly and everything. In the 3D printer phase, we have to see whether the sensors are performing properly or not, the material has to be feeded properly, the nozzle unit is working properly. We have to see everything in this 3D printer phase. And in the material phase, it is one of the important things for civil engineers. When among all these three phases, the civil engineers are more concentrated over the material, because the material whatever using in this 3D printable concrete is developed by civil engineers. So we know about the properties. So generally concrete, when we define concrete, we can say it's a of cement, aggregate, water along with some admixtures. So coming to the 3D printing concrete also, we need a material such that we will add some cement, water, aggregates, admixtures. In the admixtures, we use viscosity modifying agents, and along with that, in particular case, we use reinforcements. Reinforcement means generally the conversion of reinforcement means steel bars in normal usage, reinforcement. But reinforcement, if we are using a discontinuous way, that means in short and discontinuous, we'll call them as fibers. That means in the 3D printing technology, we can use these fibers also. Okay. So this is a 3D concrete printing system. I can explain this three phases over in this slide. So on the left side, this is the required objects what I want to print. Okay. So for this, the process will be such that first I have to create a model. Okay, that's a building model. So by using any software, I will create the first thing, and second thing is I have to give this model as input to my printer software. So now my printer software will simulate this model and it will give the inputs to the sensors. Now my sensors will move in all X, Y, and Z direction, and this is the final output what I will get. So this is the model, this is the object plan type, and this is the model, and this is the printing software, this is the printer, and this is the final output. So this is the technology what that is involved in 3D printing concrete. Okay. So step by step, whatever I have explained over there, it will be continued here. First thing is modeling. Okay. The second thing is printing. Thereafter, slicing. Slicing is important thing. So slicing, slice. You already know, slice is nothing but small piece. So let's take an example. If I want to print some 1 meter height building, okay, so I cannot print at once. So I had to divide this 1 meter into 10 layers. So then 10 layers means each layer will have a thickness of 0.1 meters. So it is a slice. Slice means we have to give a 10 slices of each slice having thickness of 0.1 meters. So that is known as slicing. This will be done by the printer software. Thereafter, after slicing, the layer wise assembly will be done, and the final complete output will be come. Okay. So now innovations in three in delivery system. Right up to now, we have majorly two different types of delivery system. Delivery system means the concrete what we want to deliver in the place. That means whatever we want to construct. Okay, that may be a building or structure, anything that should be delivered at the place. So this delivery can be done in two different ways. One is gantry girder, and other one is articulated robot systems. So these are the two different things what we'll use normally. So first, I will come to the first one, that is the gantry one and robotic one. So on the left side is the robotic arm. So in this robotic arm, so as we can see, this is the robotic arm, and here there will be nozzle. So from this is the nozzle. From this nozzle, the entire unit will be laid down. Okay, that means extruded. So this is the robotic arm. So it has high degree of freedom. That means it can move over 360 degrees. Okay, circular way. In any way it can move. Now come to the gantry girder. So this gantry girder says that, so this is my gantry girder, and this is the printer. So at this, from this onwards, my concrete will be extruded. So it can move in the X direction, in the Y direction, and in Z direction. That means it has three axes: X axis, Y axis, Z axis. But it doesn't have 360 degrees rotation. But whereas robotic arm has this 360 degrees rotation. Okay. So you can get the idea from this video lecture. So this is a robotic arm which has a 360 degrees rotation part. Okay. So the structure can be constructed by using the 360 degree rotation point. The material can be extruded and can be placed. Okay. Now you can have the idea of the gantry girder. So how it will move? It is a cobot. Cobot is a manufacturer. Okay. So it will move in X direction, Y direction, and Z direction. All the different directions it will move. Okay. So the material will be deposited. See, you can see here, we can adjust the length, height, and width. We have to fix here how much length we need, how much volume we are giving, and everything. Okay. So from this, what we can say is, when compared to the gantry girder, 3D, that means the articular robot will have more degree of freedom, but gantry girder will be used when we want some square or rectangular elements, so it can print. We can easily define it, the model, and it can print very easily. Okay. Now innovation in field applications. So here what is a field application? What I am talking is, in previous days concrete will be constructed normally. Okay, that means inside we'll go and we'll place the concrete and we'll lay down all the structures. But now there is a prefabrication technologies there. So if we want to prefabricate some material, or if we want to fabricate and we want to place them on the site, or if we want monolithic, so in the A part, you can see that the concrete will take into the industry, and there the prefabricated elements will be prepared. This prefabricated elements will be transported to the site, and there the assembly will be done. So it's one process. It's the first process. The second process is that at factory 3D printing of formats and on-site casting. So here the format printing in factory, concrete casting will be done, element transportation, assembly of elements. And here we can take the printer also over the site and we can print over there itself. Okay. And finally, on-site printing. That means we'll take the printer and their pumping and printing on-site, everything will be done. Okay. So these are three different ways at present. No, I cannot predict in future. At present, these are the three different ways what they are using. In future, it will definitely vary because it all about the innovation. At present, the innovation whatever available is these two delivery. One is articulated robot system, and second one is gantry girder. And these are the different application points, how prefabricated and all these things. In future, if someone of you have developed a new thing, and if you have taken the patent, or if you have given the innovation on all these things, then it will be further modified. Okay. So now coming to the innovation of materials used. So I have shown this slide three different types of concretes. The first one is the conventional concrete, and the second one is the SCC, that is self-compacting concrete, and the third one is the 3D printable concrete. So the conventional concrete, in the general conventional concrete, what we'll use is we'll use aggregate about 80%. When compared to binder, aggregate will be about 75 to 80%. In the aggregate also, coarse aggregate will be of major content and the fine aggregate will be lesser content. So these are composite with conventional concrete. But when we use SCC, SCC means which will be self-consolidated concrete. Okay, in the SCC concrete, what we'll do is we'll increase the binder content and fine materials. That means when compared to coarse materials, the fine materials will be more SCC. So the fine aggregate will be more and the coarse aggregate will be less. Now come to 3D printable concrete. At present, the figure what I'm showing is at present. In future, I can't say anything because the technology will vary. It will not be constant like this only. So at present, what we are using, the binder will be more, the fine aggregate will also be using, and the coarse aggregate also using. But the coarse aggregate size, whatever we are using, is very less. That means generally coarse aggregate. How can we define coarse aggregate? The aggregate which is having a size greater than 4.75 mm. But at present, we are using 8 mm size only, because if the size is greater than 8 mm, it will be difficult. Because why difficult means, the concrete should be extruded from the nozzle. So it all depends upon the nozzle dia. If the nozzle dia is 20 mm, it can extrude up to 10 mm aggregate. But if the nozzle dia is only 10 mm, it cannot extrude more dia of the aggregate. So we have to fix for smaller dia of the aggregate. That means up to 8 mm like this only. Okay. So now coming to the concrete mix, already in the before slide I have shown the conventional and SCC. Already the conventional concrete have the IS 10262, and the SCC is also having the same in the IS 10262. IS SCC also they have given the mixed design how we have to follow. But for 3D printable concrete, there is no standard or no certain set of things how we have to design. So the mixed design of the 3D printable concrete says that first initially we'll mix the design. That means it's like a iterative process. Iterative process means first we'll do a thing. If it is success, we'll complete it. If it is failure, then again it will start from the scratch. Again we have to do the mix, and again you have to give to the printer. The printer will pumpable. If it is pumpable, then it will be go to second phase. If it is not pumpable, again it will go to the starting. Again I have to design the mix. Okay. So okay, then we can say if it is pumpable, the mix is successful. We can't say like that. It should be pumpable. The first thing is it should be pumpable. That means the mix should be able to be fluid. That means it should come from the nozzle. That's the pumpable. Extrudable. That means the mix should be completely come out from the nozzle. Completely from the nozzle. That is extrudable. And finally buildable. So these are the three important properties that 3D printable concrete should have. First one is pumpability, extrudability, buildability. So pumpability means the viscosity. That means generally in the concrete there will be, if it has more viscosity, then the concrete cannot be pumpable easily. So my 3D printable concrete should be such that it should have less viscosity, it should have less segregation resistance, so that my concrete will be easily pumpable. After pumpable, it should be completely extrudable. So whatever I have given the mix, it should come entirely from the nozzle out. That is extrudable. So after extrudable, I have to see whether it is buildable. Buildable means now, as I already have mentioned, if I want to construct some 1 meter depth building, so I will divide into 10 different slices. Each slice will have zero point 0.1 meters depth. So I have first extrude one first slice, that means 0.1 meter depth. Okay, after that the second layer will come onto the first layer. So the first layer should have the capacity to hold the second layer. Okay, అంటే ఇప్పుడు సింపుల్ చెప్తున్నాను రమణ. ఇప్పుడు కాంక్రీట్ ని మనం నాజిల్ నుంచి బయటికి పంపించినప్పుడు 10 డిఫరెంట్ లేయర్స్ లో పంపిస్తాం. సో ఫస్ట్ లేయర్ వచ్చింది బయటికి, ఒక లేయర్ వేసాం, ఫస్ట్ లేయర్ వేసిన తర్వాత సెకండ్ లేయర్ ఏం చేయాలి, ఈ ఫస్ట్ లేయర్ మీదే సెకండ్ లేయర్ రావాలి. రావాలంటే ఈ ఫస్ట్ లేయర్ కి ఏం రావాలి, అప్పటికి దానికి కొంచెం స్ట్రెంగ్త్ వచ్చి ఉండాలి. ఈ వచ్చి పైన వచ్చే లేయర్ ని ఈ లేయర్ బిల్డ్ చేసుకుని కెపాసిటీ రావాలన్నమాట. సో దాన్నే మనం బిల్డబిలిటీ అనమాట అంటాం. ఓకే, సో ఈ బిల్డబిలిటీ చెక్ చేసినప్పుడు ఎన్ని లేయర్స్ అది బిల్డ్ చేయగలుగుతుంది. సో ఇవంతా కూడా ఇట్స్ మెజర్. ఓకే, ఇదంతా కూడా ఇట్స్ ఎ ట్రయల్ అండ్ ఎర్రర్ ప్రాసెస్. ఇవన్నీ కూడా పాస్ అవ్వాలి. ఏదైనా పాస్ అయితే అప్పుడు ఫైనల్ గా ఐ కెన్ సే మై మిక్స్ ఇస్ సక్సెస్ఫుల్. ఏ ఫేజ్ లో ఎక్కడ ఫెయిల్ అయినా సరే వీ హ్యావ్ టు గో బ్యాక్. మధ్యలో సార్ మీరు యూ సెడ్ దట్ పంపబిలిటీ, ఎక్స్ట్రూడబిలిటీ అండ్ బిల్డబిలిటీ, దెన్ వై యు ఆర్ డిస్కసింగ్ అబౌట్ ద షేప్ రిటెన్షన్ ప్రింటింగ్ ఓపెన్ టైం? బికాస్ మనకి షేప్ రిటెన్షన్ కూడా చాలా చాలా ఇంపార్టెంట్. ఒకసారి ఎక్స్ట్రూడ్ అయిన తర్వాత మీరు ఏదైతే షేప్ ఇచ్చారో, ఇఫ్ యూ వాంట్ టు టేక్ సమ్ రెక్టాంగిల్, ఇఫ్ యూ వాంట్ సమ్ సర్కిల్, సో ఆ షేప్ లో రావాలి. ఎక్స్ట్రూడ్ అవుతే సరిపోదు, ఈ షుడ్ గెట్ షేప్ వాట్ హ్యావ్ గివెన్ టు ద మోడల్. ఓకే, ఆ షేప్ లో వచ్చిందా లేదా, ఆ షేప్ ఉంటుందా లేదా, రిటైన్ అవుతుందా లేదా, అలాగే ఓపెన్ టైం సరిపోతుందా లేదా. ఓపెన్ టైం ఏంటంటే మనకి జనరల్ గా తెలిసిందే మీకు, కాంక్రీట్ ఇనిషియల్ సెకండ్ టైం చూసుకున్నాం అనుకోండి, గ్రేటర్ దాన్ 30 minutes, అంతే కదా. ఈ 30 minutes లో కూడా మనం ఏదైతే చేద్దాం అనుకుంటున్నా అదంతా చేస్తాం. ఓకే, సో అలాగే ప్రింటింగ్ ఓపెన్ టైం అంటూ ఉండాలన్నమాట. ఆ ఓపెన్ టైం లేదనుకోండి, సెట్ అయిపోయింది అనుకోండి, నార్త్ నుంచి ఎక్స్ట్రూడ్ అవడం అనమాట. సో ఇవన్నీ కూడా చూసుకోవాలి. ఇవంతా పాస్ అయితే దెన్ ఐ కెన్ సే మై 3D కాంక్రీట్ mix is successful అనమాట. సో ఇట్స్ వెరీ ఛాలెంజింగ్. సో యాజ్ ఐ ఇన్నోవేషన్ థింగ్ యూ కెన్ టేక్ దిస్. ఓకే, మీ ఫైనల్ ఇయర్ లో కానీ థర్డ్ ఇయర్ లో కానీ ప్రాజెక్ట్స్ కింద తీసుకుని, సో మీ దగ్గర నేను ప్రింటర్ ఉండాలని చెప్పలేను, బికాస్ మా దగ్గర కూడా ఇనిషియలీ వీ డోంట్ హ్యావ్ ప్రింటర్. సో వాట్ వీ డిడ్ ఈస్ వీ హ్యావ్ యూజ్ మోటార్ గన్స్. మోటార్ గన్స్ ఉంటాయి కదా మీకు తెలుసు, మోటార్ గన్ తోటి పంప్ చేస్తారు. సో అలాంటి మోటార్ గన్స్ అవి తీసుకుని, సో మేము మిక్స్ డిజైన్ చేసుకుని దాంట్లో వేసి దాన్ని పుష్ చేసి, బికాస్ మనం ఇక్కడ 3D ప్రింటర్ ఏం చేస్తుంది, పైనుంచి పుష్ చేస్తుంది. ఇక్కడ కూడా మేము జస్ట్ పైనుంచి ప్రెషర్ అప్లై చేసి ప్రింట్ చేసాం అనమాట. ప్రింట్ చేస్తుంటే ఫస్ట్ లేయర్ పంప్ అవుతుందా, ఎక్స్ట్రూడ్ అవుతుందా, నెక్స్ట్ ఒక లేయర్ పైన ఒక లేయర్ వస్తుందా, సో ఇలా సెట్ ఆఫ్ థింగ్స్ చేస్తున్నా ఉన్నారు అనుకోండి, అప్పుడు మీకు ఒక ఐడియా వస్తుంది. ఒకసారి ఐడియా వచ్చిన తర్వాత దెన్ యూ కెన్ డిజైన్ యువర్ ఓన్ థింగ్స్. ఓకే, సో అప్లికేషన్ అని చూసుకుంటే there are so many applications. House villas, we can use 3D printable and precast offices, warehouses, precast walls, fences, chinchan bridges. Already some small bridges have been constructed in the China and all other countries. And architectural works, artworks, production of precast elements, పార్క్ ఫర్నిచర్ కానీ సెక్యూరిటీ గార్డ్. మనకి ఐఐటి గౌహతిలో తీసుకుంటే దే హావ్ యూజ్ ఫర్ సెక్యూరిటీ బిల్డింగ్. సెక్యూరిటీ వాళ్ళు ఉండడానికి బిల్డింగ్ ఉంటుంది కదా, సో అలాంటి బిల్డింగ్ వాళ్ళు డిజైన్ చేశారు. సో దీస్ ఆర్ ద డిఫరెంట్ సెట్ ఆఫ్ ఎలిమెంట్స్. ఈ టాప్ 3 మన ఇండియాలో ఉన్నామమ్మా. ద ఫస్ట్ వన్ ఈస్ ఇన్ ఐఐటి మెడ్రాస్, ద సెకండ్ వన్ ఇస్ ఐఐటి గౌహతి, అండ్ ద థర్డ్ వన్ ఇస్ ద ఇది కొత్త కన్స్ట్రక్ట్ చేసిన పోస్ట్ ఆఫీస్ అన్నమాట బెంగళూరులో. ఓకే, ఈ కింద 3 తీసుకుంటే కనుక ఇవన్నీ ఫార్మ్ లో కన్స్ట్రక్ట్ చేసిన బిల్డింగ్స్. దీస్ ఆర్ ద ప్రెసెంట్, దీస్ ఆర్ నాట్ జస్ట్ మోడల్స్. ఓకే, దీస్ ఆర్ ద ఫార్మ్స్ వాట్ వి గెట్ ఫైనల్లీ. ఓకే, సో అడ్వాంటేజ్ కింద చూసుకుంటే ఆల్రెడీ చెప్పాము. వాట్ ఆర్ ద అడ్వాంటేజ్ మీన్స్ ద కన్స్ట్రక్షన్ విల్ బి సమ్వాట్ ఫాస్టర్ వెన్ కంపేర్ టు నార్మల్ కన్స్ట్రక్షన్, అండ్ ద కాస్ట్ విల్ బి లెస్ బికాస్ దేర్ విల్ బి లెస్ material wastage and less labor usage, and we have more geometric freedom and a short supply chain. Here the supply chain will be less when compared to other, because if we want some construction, normal construction, there is a long supply chain. We need material from there, from this, we need labor from there, so there's a lot of supply chain is there in normal construction involved. But whereas for 3D printing the supply chain is less. We have to take out printer where we want to print, and we have to give the input of the model and the printing concrete. That's it, we'll get the final shape. Okay, the productivity will be more and the constructability ease. So there is a lot of sustainable aspects for this 3D printing technology. Now there's when I compare this 3D printing concrete technology with conventional method in 3 different phases. I have compared first with environment phase, second cost, and third is time consumption. So coming to environment, there is a major environment friendly. How can I say it's environment friendly? Because here the wastage will be less. See, if we are making normal concrete and if we are wasting the material, so it's a very impact for the, it's a huge impact for the environment. Okay, creation of waste and dumping this waste and all will be more for normal conventional method. But whereas for 3D printing, there will be less waste. Okay, the waste reduction will be more, so there will not be less more wastage. Next, plastic resins, whatever the materials that are generally recyclable can be used, and pollution will be less. Okay, compared to now, come to cost. Cost means the material cost will be less, and the labor cost will be less, and the printer does most of the work. So whatever we use for the skill labor will be less. So initial investment will be more, I can say, because if we need some printer, we have to use some 20 or 30 or 50, nearly 50 lakhs. We have to initially purchase the printer. After getting the printer, it will be somewhat less costly. Okay, and great for business bottom line. Now come to conversion method. It involves large material cost, high labor cost. The laborers do most of the work and high overall cost. The time consumption, the time is a very important factor because we can construct the 3D printable building in just 1 to 2 weeks. Within 1 or 2 weeks we can construct entire building by using this 3D printing, but whereas you can see conventional method, it will take somewhat more time. Okay, so now coming to the main important task, that is the challenges. So what are the challenges that will be encountered in this 3D printing? So the challenges are divided into 7 different categories. The first category is the material. So the material what I have to use should be printable. Already explained in the mixed design part. Whatever the concrete I am using should be printable, buildable, and open time, and it should be extrudable. So there are certain challenges. If I am using certain type of concrete, that certain type of concrete can be printable. So I have to adjust the mixed design variations. And if it is printable also, it can be buildable. It can't have that strength, initial strength. So I have there's a little bit of challenges in this material aspect. Now come to 3D printer. 3D printer aspect means there are different types of 3D printer. In the Gantt grader also, it all depends on the dimensions. We'll have a 1 by 1 by 1 meter. That's a lab scale model and a bigger one. So it is all about the scalability and the direction dependency. As we already discussed, when compared to gantry girder, the robot printer has more degree of freedom, but that robot printer is somewhat costly. It costs about 1 to 2 crores. So that much amount we can't spend on that. So I will have somewhat direction redundancy is there, and there will be geometrical limitations when we are using this gantry girder. It cannot be used for a curved shape and all these different shapes. And software loader also. Right now, some companies have taken these patents for this printer software and all these things. So there is no open source software right now available. So there is these are challenges. These challenges you have to take and you have to overcome and you have to innovate. Okay, there is a lot of scope for the innovation in this 3D printing. Okay, and architectural and design, extension of building services. If you are constructing normal building for mechanical, electrical, plumbing work, MEP works, we will keep some spaces like that. But when we are using this 3D printing building, we there is a need for extrusion of building service separately. So there is a point of structural integrity also there, and the new design principles have to be followed because here we'll think that the material is isotropic. That means the behavior will be same in all directions, but we cannot say because if I am printing in X direction and later going to y direction, so in X direction the properties will be somewhat different to y direction. So at present there is no certain set of rules and regulations or codes how to design, how to print, how to test. So all these things have to come in the future. So there is a lot of scope. And next, coming to construction management. So how to do the cost estimation for this thing, how to do the construction site setup, scheduling. At present, if we need for normal building means we will use MS Project or Primavera for this entire scheduling and all this process. But for 3D printing technology, we have to see how it will be there. And stakeholders also skeptic. That means if I want to build a building, generally, if you or someone is the client is someone who wants to build his own structure, that may be building or anything, then generally we will go for conventional thing. That means I will go for normal thing because I don't completely rely on this 3D printing because as it is new and there is no certain codes or case studies and there are less types of buildings available in the market. So I will be somewhat skeptical. I cannot be say I can do like this like that. Okay. Next, there is a less demand for workers also because if it is normal construction, there is a large involvement of human labor and all these things. But while we are using this 3D concrete printer, just the demand for workers will be reduced, and also if someone want to work on this also, they need to have the special skills such that how to operate this 3D printer and how to give the 3D model and how to slice this and everything. They have to get the extra knowledge. New skills are needed and regulations liability. So as I said, there are no codes at present and there will be certain liability issues. So these all are the challenges. So you can take any of this challenge and you can work on this challenge so that you can incubate it and you can convert it into startup. So there's a large set of potential is there in this 3D concrete for innovation. Okay. So accomplishments using this 3D, that means by using this 3D printable concrete, what are the different accomplishments that have done around the world? So this is a paper, research paper, it was published by Buswell 2018. It is in cement concrete research. Okay, in this paper, what they have highlighted is that the 3D printing concrete technology have been started in 1997, around 1997, and the growth has been exponential. You can see the curve over here. Okay, so there are number of products. The products have been exponentially increased. Okay, so that means there is a lot of still in this sector. Okay, so this is the world's first 3D printed house. It was built in 2017 in France in an area of 1025 square feet interior space. So it takes about 54 hours to build this building, and they have used the robot printer. And this building cost is somewhat 20% cheaper. And that means when compared with the normal construction, it is somewhat 20% cheaper, and it has good thermal insulation and air circulation is more. Okay, and this is the first 3D printed bridge. Okay, it's in London. It's 2015. So it's on the Amsterdam near, and the company is also Amsterdam robotic based company. And the length of the bridge is 12.2 meters. Span length is about, and the width is 6.3 meters. The entire weight is 6,000, and the material uses stainless steel. Okay, here the printed one is about stainless steel only, and it's used for pedestrian cyclist traffic. That means normal loading, not extreme loading condition, normal lightweight traffic. Okay, okay. So some of the 3D printable concrete houses around the globe, this is the Germany and this is Dubai, USA, India, Colombia. So different set of countries are using this 3D printing concrete technologies. Okay. So now I'm coming to now my main concentration is in India. So how the 3D printing concrete is being used in India. Okay. So at present in India, we have divided into four different things. The first one is 3D printer manufacture. That means what are the printers available in the market? So who are the manufacturers? That's the first thing. Next, 3D printable concrete material. That means what are the concrete available for used for 3D printer? So who are the manufacturers? And what are the companies that are playing the role in building all these things? And what are who are the service providers? So four I have categorized into four different things. Coming to the first one, printer manufacturers. So in India, these three are the companies: Swatsa, Deltasys, and Simply Foods. So all these three companies are manufacturing these printers. The printer may be gantry one or robotic one, so they can make anything, and they are marketing themselves. Now coming to the materials, that means what are the concrete? See, the concrete whatever we prepare is not adaptable for 3D printing concrete, so it has to be a special one. So we have to design the mix, we have to test certain things. So like this, these two companies like MYK, Laticrete and Sika, so these two are entered into the 3D printable concrete materials like concrete or binders, all these things, and aid mixers also, they are preparing aid mixers also. Now coming to the legacy companies, which companies which are building by these 3D buildings that by using the 3D concrete. The first one is L&T, Godrej, and Indian Cements. So all these three companies are having their own printers, and they will bought the printer from these three companies, and they are constructing all these different types of things. Okay, and the providers, that means for 3D printer there is a need for service. Those service will be provided by Hamilton Labs or Akeksha Robotic. Okay, so these are the two companies which will provide the service. I'm talking only in India, because when we go to foreign, there will be Cobord. Cobord is a larger unit, okay, but in India there is a less share for them. In India, the share will be shared by Twatsa, Deltas, and Simply Foods. So, like a case study, I want to say about a case study in India, and it's the first 3D printable building in India. Okay, that is nothing but in IIT Madras. Okay, this is the building which is printed. Okay, these are the different views of that building, and this building has been completed in 2018, and this was done by Twatsa company. Twatsa is a company which was started by the alumni of IIT Madras only. So this is the plan layout of the entire building. Okay, hall, kitchen, veranda, bedroom, and everything. So this is a 3D model what they have rendered. Okay, this is the interior view of the room. Okay, so about the brief specifications, the product name and all these things is the IIT Madras. It is located in IIT Madras and it is of a 600 square feet area. The total cost is about 5.5 lakhs and duration in 21 days they have constructed the entire building. So in 21 days they have constructed the entire building and start using, and they have built in 2018 and this done by Twatsa, and the materials used by concrete mix ordinary. Generally what they will do is they will not give the materials whatever they will use, because if they have given means if anyone can use, so they will not leak all those things. So just we'll go through this video once. So it is the India's first 3D printed house, and this product has completed in 21 days. Okay, the first stage is the design. Okay, in the design we'll go for the plan and everything. Okay, the second is design development. So this is the rendering part by using the 3ds Max software or SketchUp Pro. Okay, so after this, we have to go for pre-production stage. Okay, in the pre-production stage, we have to in the pre-production stage we have to see the panels. What are the panels we need? What we have to lay down a 3D concrete, and what are the different slicing? What are the thickness of the layers? Everything we have to see. Uh, the important thing is it's a offsite. Offsite means, as I said before, it will not be printed on the site. In the Twatsa company, they have prepared all these panels, and after they bought to the site and they have cast it over there. Okay, so it's a offsite one. So these are the panels. So this is a gantry girder. So by using this gantry girder printer, they are manufacturing all these panels. Logistics coming to the how to carry all these things, because they will be way nearly 100 to 200 kgs. So they have to transport all these things to the site, to IIT Madras. So logistics part. Now, now it's the important part of on-site assembly. So here on-site assembly means first we have to mark. Okay, that means we have casted all this in the site, not in the site, in the company. Okay, now we have to lay down in the site. So first we have to mark. Okay, after marking we have to do the excavation part. What we will do for normal thing. Okay, so excavation will be done. So after excavation, they are doing the shuttering part also. Shuttering part will not be included in the 3D printing concrete. So shuttering part will be doing here for foundation, shuttering all these things. So after foundation, completion of foundation, then placing the panels. Yeah, now foundation is complete. Now the panels will be placed and the connections will be given for each and every panel. Okay. Always the construction will be anyway. The construction will be always from bottom to top. So it will be from bottom, then after top. So arranging the panels and everything. See, now ground floor has been completed. Ground floor has been completed. Now they are placing the next floor. Okay, the top part. For bonding, they are using different resins like these things. Okay, that means to bond the bottom layer and the top panel, there's a need of bonding. Okay, they are laying all those things. Wait a second. Wait a second. Oh, sorry, sorry. It's my end. From my end, it's a problem. So they erected a top also, top post. So like this, they have taken nearly 21 days for the entire completion of this building. Okay, as a time lapse, will show just like that, but it will take time. Okay, Twatsa is the company which has designed all these things. It is a startup done by IIT Madras. Okay, okay, alumni. So this is the house that is being printed completely, final phase. After 21 days, this is the form that we got. Okay. Yeah, these are the things. That means actually some of the to sit like the benches and everything they have cast all those things also. Twatsa. Okay. Now we have discussed about the India's first 3D printing concrete that is building. Now let's go into the research part. That means lab scale model. Lab scale. How can you define lab scale? Means before going into the site, first initially we have to check the 3D printing material. That means whether the material is successful or not. So for testing the material, we need a lab scale printer. Okay, that means lab scale printer can be size of zero point 0.5 by zero point 0.5 by zero point 0.5 or 1 by 1 by 1 like this. Okay, so for research purposes, a prototype model of the 3D PC is required. The main target is the motion control. Okay, whether the motion control is perfect or not, the material properties is good or not, and the material dispensing system, that is nozzle and everything is perfect or not. To study all these things, a lab scale 3D printer is required. So coming to this lab scale 3D printing, this is the first lab scale 3D printing developed. Actually, it has been refined so much now. It's the older one. It consists of, this is the nozzle over here. So from the top, the concrete will be poured and it will be extruded from the bottom. So the size is having a 400 by 300. It's of 400 300. And the flexible hose, and this hose can be moved again against X direction, Y direction, Z direction, all these three directions. So later on, the lab scale model has been developed and is supplied by Deltasys to IIT Bombay. So IIT Bombay is having this particular gantry girder type. So in their lab, they are designing all these things. Now coming to the printer, what we have in this VR Siddhartha. So we are having this install this 3D printer. I think last month. Before installing this, we have worked with a motor and all these things. So this is the thing what we have. So this printer is having the nozzle and extruder and all these things over here, and this will move in all directions: X, Y, and Z direction, all the three directions. So initially, what we have to give is that we have to set up what is the extrusion type, okay, and what is the acceleration speed, and how we are developing the material motor type, okay. All these things we have to give input. So this is the software which was provided by Twatsa, because we got the printer from Twatsa, so they have given us this software. After this first, the second will be the layers. So I want to print some circular shape things, so I have to give the number of layers. So here, if I have to give the number of layers, overall layers, 8 layers it required. So material, how much material required this for this 8 layers, it will give entire thing. And layer number one, how much materials will be required and how much speed it will be give. So all these details we have to give as input, okay. Then this all about the sensor directions. That means whether if you have to move in the X direction or Y direction or Z direction, I have to give specify the dimensions, how much it has to move. Okay, 1 mm or 10 mm or 100 mm or 500 mm. So in this direction, I will increase the Y direction. In this X direction, for Z we have given separately. That means if we have to go up or down, we have to specify separately. So all these dimensions we have to give here as input. Okay, and I have to fix the motor speed and everything. So I have given the panel. Okay, so this panel has to be extruded. So I have to fix how many layers I need. So I need 91 layers, and the total material I required is 625 kgs. So overall time it will be about 2.37 hours. Okay, so depend upon that, it will fix each layer. For each layer, how much material it required, how much speed, how much time it will take. So like this, first it will lay down the first layer. After the first layer, the second layer, the printer will come again. It's to origin. Again, it will print the second layer. Again, it will come back. So like this, it will completely print the 91 layers. Okay. So basically, we have done with star-shaped, circular-shaped, and as it's the initial phase, and it is working for the research purpose. So it is the dry run. Dry runs means without material. Without material, how my printer will run? Okay, in the X direction, the Y direction, Z direction, all these things. It's the dry run. Now you can see the wet run. That means after giving the material, feeding it to the feeder. So from the nozzle, see, my material will come layer by layer. So see, the bottom layer should have the capacity to hold the top layer. So how many layers I have designed will be given into the software. So my model will be ultimately hold all the layers. If it has all these three properties, what I said, that is pumpability, extrudability, and buildability, then finally my thing is success. Okay. So actually, we don't have the automatic feeder. So after completion of the material in this, we have to feed it manually only. Okay. There are automatic feeders also. Automatic feeder means directly it will connect to the concrete mixer. So after once it's been emptied, the mixer will pour down the material. But now we don't have the facility, so we load manually only because for this one only it costs around 30 lakhs for us. So as it's a research purpose, so initially we don't want to spend further amount. Okay, if we have the consultants and all these things in future, we'll go for that. So these are the different types of shapes, and we have cached all this with the material whatever we have prepared. We haven't bought any material from outside, so we have designed the material, and with the material we have casted. So actually we have designed the material. That means we have designed the concrete mix. Along with that we have printed. So we were successful in somewhat way, but further emphasis is needed for us in the model because right up to now the models available are these shapes only. But if we want further shapes, that means we have to create the models and we have to slice it into number of layers. So we are doing the particular research in this area. So when we talk about this 3D concrete, the styling features, what I can observe is there is a faster construction as the walls and foundation can be printed in days, as you can already show through that IIT Madras. They have printed the entire building 21 days, so it's in days only. So there is a precision with respect to construction because why I'm saying precision is if we are using some human elements, then there is a chance of error. But when machines are involved, so there's a lesser inaccuracy is there. So there's a higher pressure is there. So India's first concrete 3D printer is done by layer, and it's a in-house product which is done by the Swatsa company. So there's a less waste and there's increased affordability due to less wastage and reduced labor intensity. But I can't say at present we can do everything with this 3D printing technology because if I need to build something, I need printer. But now at present, the printers are somewhat costly. These 3D printers cost about 30 to 50 lakhs or 1 crore. So at present, there is less scope for this one. But in future, if we have designed somewhat less cheaper printers, then there is a further more scope to use in the construction industry. So there's a high chance for innovation in this. You can see it's all about the elements and all the motors running sensors. So if you have some interest in the sensors and all these things, you can work in this area and you can design some cheaper printer which is economically feasible for our country, which is somewhat economically less when compared to other countries. So labor safety is very high because here the use of labor is less. So there will be as the robots are involved in this, the labor safety is more. Economical aspect, the cost of construction can be brought down. The cost of construction will be brought down, but initial cost will be more. Okay. Sustainable aspect means the carbon footprints will be less because in this while come to our case, we have designed the 3D print material by using bag ash, flash, all these materials we have tested and are successful. So all these materials, industrial waste can be used. Thereby, I can reduce the footprint and the overall material quantity can be reduced because there will be less wastage. And using construction and demolition waste, C&D waste. But that means if you want to use the aggregate, we can use the C&D waste also, but somewhat finer. We can't go the coarser meters like 10 mm, 20 mm, so we have to use up to 8 mm only. The suitability and availability increased for all weather conditions, and it is available. That means everyone can use it. But the main limitation is technology adoption is difficult because it's a new technology. Adopting this technology is somewhat time taking and also costly. Okay, and also there is a certain set of model provisions is required for this one. Next, against natural, that means generally if we are designing a building or anything, what we'll do is we'll check for seismic forces, wind forces, and all these things. But over here, these things are not there in depth. So in depth presentation is needed. So finally, my concluding remarks is that technology of 3D printing is still young, and there's a lot of scope, and there are a lot of limitations. You can investigate, and you can further come up with some companies or startups. Anything. There's a lot of scope if you have interest or if you have passion, if you want to establish yourself a company for you, so it's a better idea for you. And this could change the game for construction industry because at present the construction industry in the present construction industry, the cost will be mainly due to the material as well as with the labor cost. So when we are using this 3D concrete, the labor cost will be reduced significantly. So it's a huge potential for the future. So developing countries like India, this will be mostly successful, like Pradhan Mantri Awas Yojana, Swachh Bharat, and all these things, toilets, construction of toilets, and for all the people. Although the current adoption remains low due to technology not being broadly developed, because as you can see, only three companies are developing these printers, so there are less competition. So they will supply us with more cost. Okay, if we have more competitors are there, then somewhat pricing will be reduced. So if we have focus into this, it will be very useful for our Indian country. Okay, and it is very safety and durability, and it's safe to say that it has potential to make a positive change in the industry. So in the construction industry, what we are seeing will be entirely revolutionized by using this construction 4.0, industrial revolution 4.0, where we're using automation in a highly speed. Okay, along with this, the BIM, already you have known the BIM, the building information modeling. So if you have integrated this 3D printing concrete with the BIM, building information modeling, it will be very successful. So I can advise some students to work in this area of implementing the 3D printing concrete in the BIM. It will be very useful. Okay. So with this, I will end my session. So if you have any queries or anything, you are feel free to ask. Hello.
Hello,
Yeah,
sir.
Srijan. Yeah. Uh, ఏమైనా
Am I
queries
audible?
ఉన్నావా? Any queries? Anything needed?
Okay, I have one question, sir.
Yeah.
Hello,
చెప్పండి Srijan. Yeah. Ask me.
sir.
Hello.
How the cost of concrete of 3D printing compared to the traditional concrete?
Okay, Srijan. Okay. Got your point. Okay. When we compare the cost with the material, we have to see the technology also, because here the wastage will be less. Okay, when we compare this concrete, the 3D printable concrete with the normal concrete, in the normal concrete construction, the wastage will be more, but here the wastage will be less. But as you said, here at this point of view, at this point of time, I cannot exactly say whether the cost will be less or more, because if I am using normal concrete construction, I can say that I am using M30 grade concrete or M40 grade concrete. Okay, but at present I cannot say what is the strength of the concrete 3D printing what I am using. Okay, what I will see is whether it is buildable or not, whether it can resist the layers or not. Okay, so I cannot compare at this point of time both the middle. Okay, but in future, the cost will be definitely decreased, because at present only two or three companies are there which are producing these metals. But later it will be reduced when we use these waste metals such as silica, sorry, bagasse ash, and all these things. Yeah. Next question. Yeah.
Any environmental benefits associated with using 3D printing?
Yeah. There's a lot of environmental benefits. As I pointed in my second slide, there's a lot of sustainable benefits by using 3D printable concrete, because the wastage will be less, and we are using the waste materials. Along with that, as the machine is, we are using the automation, so everything will be friendly. You can say, because as we are using automation, so there's a chance of this gas, but there is no chance for, because we are using the printers. They will not emit any gas and all these things. Just they will print the whatever the material we have given them. They will print. So environmental, it's somewhat environment friendly when compared to normal concrete.
Okay, sir. Thank you.
Yeah. Anything from students or anything? Because the students have to focus mainly, because your future will be entirely on automation. because what when I am studying my engineering is about I think 15 years back. That one is entirely different from the engineering nowadays. Okay, now everything they need in terms of innovation. Okay, what is the thing you have developed in our time? Just what are the what you learned, but now what is the product? What is the output you did? Okay, so they are expecting, the industry is expecting from you. So you have to come up with the ideas and you have to work towards that. Okay. Any further queries? Anything? Or if
No
you
questions, sir.
feel, yeah, if you feel say anything, just take my mail ID. You can WhatsApp, mail me. Okay, teja@vsiddhartha.ac.in. If there is any chat box, I can type, but I won't find any chat box over here. Yeah, here is the chat box. I will type. Okay, your Srijan is also having it. Okay, yeah, this is my mail ID. You can contact me.
Okay, sir. Sir, there is no question, sir.
Okay, okay,
We'll
Srijan.
close the session with proper thanks.
Okay, Srijan. Bye.
Okay. So, good afternoon, all. So, I stand before you today with immense gratitude and emphasis as we conclude this insightful session on innovation and recent advancements in 3D printing concrete technology. On behalf of Pace Institute of Technology and Sciences, I extended my heartfelt thanks to all the designated speakers, Dr. R. Raviteja sir, and organizations who have contributed to making this event success. So, in rapidly evolving era of construction, the innovation and technology has paved the way of groundbreaking advancements in the field of 3D printing concrete. So, today we had the privileges of delivering the depths of these innovations and exploring the immense potential they had for revolving the construction industry. Sir, am I audible, sir?
You are audible, Amma. Yeah, you are audible.
Okay. So our gratitude extends to our esteemed speaker, Dr. P. Raviteja sir, shared their experiences and insights. Your presentation have been enlightened, giving us a comprehensive understanding of the challenges faced and the solutions for the realm of 3D printing concrete technology. So in the last but not least, a heartfelt thank to you, each and every one of your present here. So your presence has made this event meaningful. As we despair, let us carry forward to the knowledge and gain and the connections made during the conference. So let us continue these ambitions of innovation forecasting for the growth of 3D printing concrete technology and propelling our industry into the horizons. So thank you, sir.
Thank you, Srijan, and thank you everyone for giving this opportunity. Okay.
Thank you,
Feel
sir.
free to contact me
Thank
if you
you,
have
sir.
any queries and anything. Okay.
Okay,
Okay,
sir.
that's it from my end. Okay. Srijan, I'm leaving. Okay, is it fine?
Okay, sir. Thank you, sir.
Okay. Okay, everyone. Bye. Bye.
Adige? Leave.